Good morning, everybody, and thanks for joining us as we introduce Redshift. We're going to start today with a brief overview of AWS, Amazon Web Services, and database services in particular. We'll then look at the reasons we created Redshift and introduce you to the service itself. Then we'll show you what it's like working with Redshift. And this will include a live demo from our partner team at Full 360. Finally, we'll wrap it up with working examples of the type of use cases that are becoming very popular with early adopters of Redshift. So a quick introduction to AWS. This is a very simple view of the set of services we offer. Compute, storage, and data services, database services, are at the heart of the solution. What we do is surround these core offerings with a range of supporting components like management tools, and networking services and application augmentation services. All this is hosted within our global data center footprint that allows you to consume services without having to build out facilities or equipment. Just one moment, we're just going to pause for a second. Sorry about that. The interesting thing about all this infrastructure, that as much as we call it the cloud, and people like to refer to that term, there's a lot of equipment powering these services. And in fact, every day, AWS adds enough server capacity to power Amazon.com in 2003, when it was over a $5 billion enterprise. So when we look at database services, one of the core foundation services of the AWS stack, we're really focused here on scalable high-performance application storage in the cloud, and it's really structured. So the services by name, we talk about in-memory caching with Elasticache. That is a managed Memcached service. Or for relational database workloads, Amazon RDS, Relational Database Service, provides a managed experience for MySQL, Oracle, and SQL Server. DynamoDB is a fast, predictable NoSQL data store aimed at extremely high workloads and is generally regarded as the place to start developing new apps. If it doesn't fit in Dynamo, then that's usually because of complexity of the code, but the simplicity of starting with Dynamo and the ability to scale that limitlessly makes it a very compelling first-time data store. And finally, Redshift, the fast, powerful, fully managed database, data warehouse in the cloud. And this is obviously going to be the focus of today's talk. So why data warehousing in particular? So the short answer is it's our customers. Our customer feedback was consistently strong about the need for a data warehouse service in the same style as RDS, the Relational Database Service. So requirements were generally in response to the price performance value the customers wanted and felt they were not getting from other options. The ease of use is always a requirement for customers looking to improve their productivity, especially when small teams attempt to achieve much greater things with far fewer people. The cost model is also almost as important as having a low price. And on-demand, reserve capacity, these type of options are all very favorable. Utility-style pricing is always a popular request when customers are seeking guidance on a new service. The data warehouse ecosystem is very healthy with technology vendors, especially those doing data movement and business intelligence. And because of this ecosystem, it was very important that we had an open and flexible approach to supporting these tools. So it was because of this input that we decided to build Amazon Redshift. Amazon Redshift is a fast, fully managed petabyte-scale data warehouse service. Redshift, the name, refers to the astronomical phenomenon, which was first used by Edwin Hubble to determine that the universe was expanding. So Amazon Redshift, as the petabyte-scale data warehouse service in the Amazon cloud, it was designed to help customers make sense of an expanding universe of data and to function as a central component in a big data strategy. We'll get more into detail on Redshift's big data role shortly, but first let's look under the covers and see what makes Redshift so special. The objectives were fairly simple. Redshift was conceived with a core set of objectives, very simple, and basically to be faster, cheaper, and a whole lot simpler than any other data warehouse alternative. To achieve these goals, every aspect of the service had to be optimized for the workloads that you experience in a data warehouse. There was an extensive use of automation, as you'd expect, and I/O efficiency in particular is especially important for performance. And eliminating unnecessary I/O has been an area of great focus for the Redshift team. So how does Redshift dramatically reduce I/O? There's actually a number of ways. Firstly, disk storage is directly attached to the Redshift servers, and large block sizes of 1 megabyte are used. There's also a concept called zone maps, and these are used to effectively skip entire blocks if the data requested is not contained within that block. So it makes scan operations highly efficient. A significant factor in Redshift's high performance is the use of columnar storage, and this is optimized for scan operations. So columnar storage is very different to row storage. It's a SQL database. It looks and feels like a SQL database. It has rows and columns like a SQL database. It's not different from an experience perspective to the user. What's different is how it's optimized for those scan operations. Row storage is what traditional databases use. Instead of locating data in rows in the same location on a disk, Redshift maintains column data physically adjacent. So when performing an aggregation on hundreds of millions of rows in a single query, such as calculating the average age of everyone in the database who lives in a particular state, Redshift is able to return the results very quickly. Redshift is also built on optimized hardware, custom hardware that was built specifically for high-intensity data warehouse workloads. This instance type has since been made available in EC2 and is known as the HS1 8XL. HS stands for high storage density. The 8XL was designed specifically for I/O-intensive workloads, particularly scan operations, and these are very typical of data warehouse workloads. And the high-density storage means we can pack a lot of data onto each disk and therefore get the most out of the architecture. The network connecting these servers was originally designed for high-performance computing service. They have extremely high workload demands, and that's why we have 10 gig Ethernet connecting all the nodes in a Redshift cluster. Redshift users can also provision a single XL server. So this is a new type of server that we introduced as a portion of the 8XL. And basically the idea there is that it allows you a much lower entry point of 2 terabytes to begin working with your analytical data, and also it gives you a lower point of increment to grow when you need to scale up your cluster. So the idea with this instance type is, especially with the XL, the smaller increment gives you the ability to not just start with 2 terabytes, but grow by 2 terabytes at a time. You can cluster these all the way up to 32 instances for 64 terabytes, while the 8XL currently scales all the way to 1.6 petabytes. Clusters can only contain one type of instance. It has to be homogeneous, either an XL or an 8XL. But using the resize function, you're able to move between instance types as you need. So in other words, you can scale up using the XLs in smaller increments, and when you get to a size where you think the 8XL is going to suit your workload, you can easily just resize onto that. During that operation, writes are suspended. However, read access is fully available, and so the scale-up operation is completely live. This diagram shows the underlying architecture of Redshift. The important thing here is that it's massively parallel. Everything is distributed. Everything occurs in parallel. All operations are distributed and parallelized for maximum performance. Data loading into Redshift is optimized for both S3 and DynamoDB, and these are recommended for both incremental updates as well as large data ingestion. Moving data from DynamoDB or S3 into Redshift is performed using a single command, the copy command, and this moves data rapidly, of course in parallel, and directly into the cluster. Query access to Redshift is provided through the leader node, and this uses a PostgreSQL driver for client communications. And since ODBC and JDBC are supported, This has enabled many of our partners to quickly test and certify their products to support Redshift. And if you look at the Redshift homepage, you'll see there's a partner section there, and we maintain that. So as partners certify their products to Redshift, we load them onto that page. So it's always a good way to find the partner you're working with if you have a preference and see if they're listed. If they're not, by the way, the good thing about ODBC and JDBC is that the support, it will basically work. It may not be formally certified, but the full operation is generally supported by all tools. So Redshift cluster configuration is designed for fault tolerance and data protection. Data is synchronously maintained in multiple locations within the cluster, and it's also continuously streamed into S3 for high durability. For those of you unfamiliar with S3, it's a regional service, and it provides 11 nines of durability. What that means is if you store 10,000 objects in S3, on average, we may lose one of them every 10 million years or so. With this architecture, Redshift is extremely resilient to failure, to outage, and of course to data protection threats. Disk failures, for instance, are completely transparent, and nodes recover automatically. Redshift also employs a streaming restore capability. So this is kind of the opposite of when pushing data into S3. This is the ability for Redshift to intelligently bring data back out of S3. So if there's any data loss within the cluster due to a failure of some sort, Redshift will automatically stream in the missing data from S3. So if you wanted to build a new Redshift cluster in a new availability zone in the same region, using an existing snapshot, you can issue queries against the cluster the moment Redshift is available, even though the data has yet to be fully restored, or even very little of it has even come back. This is a feature called streaming restore, and what that does, it enables you, how Redshift behaves in this situation. It first restores the specific data requested by any queries that are being issued against the cluster at that time, and it will fault in that data to make sure that those queries are satisfied. So they'll be returned against the full data set, and if there's no queries being issued, then Redshift will default to restoring the most recent data first, which aligns with typical behavior, query behavior in a data warehouse, where more recent data is generally accessed more often by reporting processes. Redshift also secures the data in a number of ways. A VPC isolates the cluster and integrates it into an on-premise data center. There's also data encryption at rest when backed up, and in transit in SSL. The encryption algorithm, we use AES 256, and it's hardware accelerated. Resize is the other function listed here, and this is I'll go through this in more detail, but it's a very popular function for anyone who's had any experience with warehouses, particularly because it's so painful when it's not accelerated by the cloud. So I wanted to just make one more point about the current state of data analysis. These are various analysts, in fact, have attempted to quantify the gap between data generated by applications and data that makes its way into the analytical environment. And the general trend, of course, as you can see on the screen, is that the gap here is large and it keeps growing. But the basic problem is that people simply cannot capture and process the volume of data that are generated in their environment. There's far more data than there is the ability to analyze and understand it. And that's something that people are missing, of course. If they capture data but they don't look into it for patterns, trends, and so on, because obviously these things fuel the business intelligence executive information systems, and obviously are designed to make better decisions. So Redshift is specifically designed to eliminate two of the major barriers to this sort of ubiquitous analytics, where we kind of promote the idea of analyze everything as long as it's easy to do and it's low cost to do. And effort and cost are the two areas that we target most aggressively. Operational data, for instance, does not find its way into the warehouse or the analytical environment, often because the cost of the warehouse prevents smaller, less proven data sets from gaining entry. On top of this, the effort required to bring data into the warehouse is often a lot. It's substantial relative to its perceived value. And so this data falls on the floor, as we say. It doesn't get put into the analytical environment. So as I mentioned, Redshift has been built and more specifically priced to change this and to allow customers to close the gap and start analyzing all their data all the time. Redshift was built with a focus on performance, price, and ease of use. The XL nodes provide 2 terabytes of storage and cost less than $1 an hour to get started. If you need more than a single node, the single node price is simply multiplied by the number of nodes you provision. You only need to remember one price. That's that 85 cents per hour for on-demand. We also have additional pricing options. We call them reserved instances. What you can do is you can basically reserve an instance or a number of instances for 2 periods, 1 year or 3 years. By reserving the instances, like for a 1 year, you save over 40% on, compared to the on-demand price, and for a 3 year reservation, you'll save over 70%. So reserved instances, when you look at them and you total them and you're looking at persistent workloads on, it costs less than $1,000 per terabyte to keep all your data online for an entire year. So let's spend a little time looking at how Redshift looks and feels. An important consideration is always the degree of enhanced productivity our services can offer. And this is the cornerstone of a managed service. In assessing the quality of effort spent around the data warehouse in particular, it's fair to say that the majority of time is spent on what we call undifferentiated heavy lifting. The activities needed to maintain a working environment, but that don't actually help improve the applications that use them. So when we talk about differentiated effort, let's talk specifically about the warehouse. If you've ever, anyone who's ever managed a warehouse or even a database in general understands that they require a lot of effort to maintain and to build. Differentiated effort is designed to increase the uniqueness of an application. Spending time on data analysis and application performance is far superior to setting up backup jobs and replacing failed hardware. Redshift employs extensive automation in order to eliminate this undifferentiated effort. This enables users to focus on their applications and leave what we call the muck to Amazon. So let's walk through a quick cluster, a quick provisioning example where we're going to build a cluster. The idea is, of course, we create it. I'm not going to do this live because we've got a live demo coming up. We're just going to walk through a few screens so you understand kind of the experience that you use when you deploy your first cluster. Create a cluster in minutes. That will be, by the way, automatically patched. OS, software, hardware, all those things are maintained independently and under the covers. As a fully managed service, Redshift does it accelerates the time to launch a new data warehouse. So this is the launch the create cluster in a few minutes. This agility, this benefit of agility that we're giving to customers is something that they really try to convert into a competitive advantage. So included as part of the managed service is automation software and operating system patching, as I mentioned. And these are, again, what we consider muck, low-level administrative tasks that consume a lot of effort, a lot of time, which we've simply automated and made a zero-effort process going forward. Another big benefit of using automation is to manage the heavy lifting associated with building and maintaining a warehouse during a scale operation. So when you're scaling up or when you're scaling down. And we're going to walk through this as an example as well. So let's look at the first screen. There's pretty much 4 screens. We're looking at what are the details of the cluster, what is the node configuration. There's some more additional configuration, then we review, and then we launch the cluster. So it's 4 very quick steps to getting your first cluster up and running on Redshift. So you populate the fields that basically specify the database that you want to run. If you select the 8 extra large node, you can see there the CPU memory storage and I/O performance is described, so you know exactly what you're getting for the instance type that you're selecting. And of course, down the bottom you get to see whether you're selecting multi-nodes, i.e. a cluster configuration, and then of course how many of those nodes you are selecting. With the XL machine, you're allowed to, of course, deploy a single node. So that number of compute nodes would be 0, be in single node function. So if we look at the extra large, we see, and by the way, 8XL is exactly 8 times XL in every dimension. So that's why we talked about one thing to remember in terms of price. The same sort of thing applies for all the other specs. So in this case, we've got the extra large, 2 virtual cores, 15 gigabytes of memory, 3 hard drives with 2 terabytes of storage. All that is times 8 in the 8XL. And of course, if you cluster 3 or 4 of these together, you simply multiply these by 3 or 4, and that's your total resource pool for your data warehouse. So in this case, we're building a 2-node XL cluster. The next stage is really when it's called additional configuration, but what we're making a decision here is if we can do effectively one-click virtual private cloud. And what that means is with the virtual private cloud, it's the ability to isolate the cluster and integrate it into an on-premise data center. I already mentioned about data encryption. That is, of course, part of our whole security and data protection offering with Redshift. But with VPC as a one-click operation, it means that even if you have data on-premise in your operational systems, Redshift is completely viable for running your warehouse workloads, because the connection we can make between your on-premise system and the Amazon cloud, and Redshift in particular, is completely protected and isolated by VPC and encryption. This is the final stage before we launch, where we review what we've done. You just get an overview, a summary of all the items that you've input. When you're ready to go, you simply push Launch Cluster, and then the cluster's up and away. So if you compare that to building your own warehouse, it's obviously a lot less effort. Now, I also want to talk about resize. This is one of our favorite functions. Customers are really enjoying this one. The resize experience in Redshift has been extremely popular, especially for anyone who's been through a scale-up exercise previously with a traditional data warehouse technology. Planning and preparation just for that sort of operation often takes weeks, sometimes many weeks. And the really scary part is when it's time to execute, the effort is equivalent to a full data store migration. So just an upgrade, an increase in resources can often mean a full data warehouse migration. So this is obviously a problematic, this is a big challenge. Redshift makes scaling up and scaling down as well. You can scale down. As long as your data fits in the target cluster, it can move. And makes it very simple, push of a button. So by selecting the gray resize option, now these are the option, the top options that are across your menu when you're on the console. I've just taken them out of context a little bit to make sure we focus just on these. But they're very easy and very visible on the main menu. By selecting the resize option, you're prompted to enter a new desired cluster detail. So you can see there, you choose the node type, the cluster type, and the number of nodes. Basically, exactly what you did to provision, but this is now a resize. Now note that even if you're currently running an XL, you can choose 8XL, and of course the other way around. The only thing about a cluster, it needs to be homogeneous as far as the type of instance goes, but you can resize across instance types anytime. There's no limitation there. So selecting the blue action button labeled resize, that puts the cluster into read-only mode while the resize proceeds. So this is what happens behind the scenes. Redshift is placing the cluster into read-only mode, allocating the newly requested cluster in its entirety. The data is copied in parallel. Remember, this is all massively parallel, everything distributed. It moves from the current cluster to the new cluster. The rate of transfer is limited mostly by the smaller of the two nodes, of the two clusters. The client continues to communicate with the leader node all the way through this operation. It's a live operation. While the new cluster is being built and while the data is being copied across. It is read-only though, so it's great for queries, but writes will be suspended. Once that copy has complete, the new cluster is now effectively the master. The DNS switches over, and the clients keep interacting. Suddenly their cluster goes into read-write mode, and they have, if they've scaled up, substantially more power. And of course, the old cluster is deprovisioned, and that is the resize function. So it's completely live. We protect the consistency of data by blocking writes and just going into read-only mode. But of course, the flexibility of this gives you two main benefits. One is you can scale from, and two, any configuration that you need. And two is, of course, each time you move, the data is striped uniformly across the new target cluster, ensuring that you have a very balanced workload, a very balanced environment for your workload. We also integrate with existing BI tools. So we've got a list of them on the screen there, and we're actually going to now move to a live demo of Redshift, and it's going to be driven by Jeremy Winter of Full 360. So they are one of our Redshift SI partners. And because Redshift provides ODBC and JDBC connectivity, most BI tools work immediately. I don't think we've found one that hasn't, to be honest. Several partners have certified their products to Redshift, so you can see a list there of BI partners. I think Jaspersoft is one that I think Jeremy will be using today. So Jeremy, you on the line?
Yes, I am.
Hi, Jeremy.
Howdy.
So thanks for joining us. We're just going to pass control to your screen. I've just got a quick question for you, specific around Full 360 and the value you provide to a Redshift customer. So Redshift is very easy to use. Customers can do a lot of it themselves. What are the sort of things you've got to help customers get the full benefit out of Redshift?
Well, I mean, generally when we do an implementation with a new customer, we do what we call a quick start, where we go into, do a site survey for the customer, and then we usually, analyze their data sets and how they intend to use them, anything in particular to their data that will require special handling. Then we usually do a fixed price statement of work where we basically get them up and running enough to to determine where they want to go from there. So we usually get them get their data loaded, get an ETL process set up, and get them started playing with their data in their database.
Great, thanks. So what have you got to show us today?
Okay, I'm going to demonstrate ad hoc querying of data stored in Redshift. The data I'm going to be analyzing is a billion-row table of simulated customer web click information representing 130 gigabytes of data in uncompressed form. Though, of course, Redshift can handle data sets much larger than this, I want to demonstrate real-time queries with a data set that is just big enough to be impractical to handle in a standard row-based database management system. Let me show you real quick my slide wasn't open. One moment. Here we go. Okay, let me show you my slide here. So, there we go. Right. Okay, so for my demonstration, I'm going to report on Redshift data through Jaspersoft, a commercial open source business intelligence tool, which has been, as you mentioned, certified for use with Redshift. In this case, Jaspersoft is running on an M1 large EC2 server in the same Amazon Cloud data center as the Redshift cluster. The Redshift database that I'm using is running on an 8-server cluster of 2 core machines, and this configuration can handle up to 16 terabytes of data, far more than we're going to be looking at today. Setting up this Redshift cluster, including the data load, took approximately 1 hour end-to-end to get everything up and ready for reporting. Let me show you here. All right, so Jaspersoft delivers reporting through a web-based interface, which can be secured using industry-standard SSL encryption. Please note that everything you see on my screen is running in a Chrome web browser. You do not need to download any software to your machine in order to use Jaspersoft. It'll work on any platform, any desktop platform that you may have. So I'm going to log in with my Jaspersoft credentials. This is actually the only time during the demo that I'll be typing. Everything else you see can be done with a mouse or trackpad. Okay, so we will start our analysis by clicking Create Ad Hoc View from the Jaspersoft home screen. The data source that I'm selecting is a reporting domain built specifically to report on the billion row table. This domain, it took me approximately 10 minutes to build through the browser interface. Very easy to bring the table into JasperSoft in order to make it available for reporting. So this screen is asking me to choose which columns I want to include in my report. So I'm simply going to pull in all of the columns into the ad hoc view designer. And I'm going to select crosstab as the report type, which is similar to a pivot table if you're accustomed to pivot tables. Right. So the first thing I'm going to do is select full data as the scope for this session to ensure that we're viewing the complete data set while we build the report. All crosstab reports require a metric, so I'm going to drag row count to the column set. JasperSoft immediately reaches out to Redshift in order to do a live query to determine how many rows are at the table. I mean, because that's the report that we're asking for here. So dragging ClickDate to the row field automatically groups the row count by calendar quarter. Let's take a second here while it's running. Remember, we're traversing literally a billion rows of data in real time. There's no caching going on here. Right-clicking, so right-clicking on one of these dates allows you to, keep only or exclude it from the report. So typically in a BI environment like this, in a large set of data, what you want to do is get to a subset of your data very quickly. So I'm just going to go ahead and select Q1 of 2000. So what this is going to do is automatically create a filter for me based on the date range of Q1. And of course, you can go down to the granular day, and those calendar controls allowing you to select what exactly is the date range you want to report on. All right, so now that we've narrowed down the data set we want to look at, we can start slicing into it. So I'm going to break out the page domain across the columns of the report. No, not subdomain, page domain. Here we go. So this represents the domain of the page that the customer navigated to while they were browsing. Let's just pop that open. All right, so next I'm going to add country to the row set. And this field represents the country the customer was located in when they clicked on the page. And we're going to continue to narrow down the geography by adding city into this row set here. So, I mean, you'll notice that these reports do take a couple seconds to complete. These same queries, if you were to run them in a row-based database, would take, easily 5 to 10 minutes to complete if they came back. I mean, you'd actually have to have a very well indexed row-based row store database in order to, to get the reports back in any decent amount of time. And also, you'd be doing a lot of unnecessarily large data movement to achieve the same results. Hence, we're getting the benefit here of the columnar storage and compression. All right, so at any time, using JasperSoft during one of your ad hoc view editing sessions, you can export your data to various file formats such as Excel. So let's just go ahead and look at an Excel report, because ultimately, when it comes to data analysis, people want to get their hands on the data to actually do something with it, do further calculations. Right now, it's cooking on the server side, getting our export done. Here we go. And we'll go ahead and open that up. And you'll see that the export to Excel is actually very nice and clean. The contents of the cells, there's no strange formulas or anything. It just actually has the value in the cell where you would want it. Unlike, some BI tools sometimes export in strange formats. This is very clean and also preserves your formatting very well. So kind of to show off Redshift itself a little bit, let's actually go to the Redshift Management Console where for this particular cluster. And this is one of my favorite features of Redshift, and DBAs out there will really appreciate this. This Performance tab gives you all the stats for the database, by time, so you can see all the CPU, the network transmits, and IOs per second and stuff like that. My favorite here, we're going to hit the refresh. My favorite is to look at the queries that have been running. So these are the queries I just ran for the demo. And with Redshift, you can hover over each of these individual queries, and it'll tell you what that query was, your general statistics, start and end time, how long it took. And this is what I really like. For any individual query, you can click on it, and it'll bring up a separate tab giving you all the details of everything that happened with that query, including the actual query itself and the explain plan, which is useful to database developers. And what I find really interesting is all the CPU utilization, all of those performance statistics for the cluster at and around the time that that particular query was running. So this way you can analyze, if there's queries that are causing spikes in your resource usage. This allows you to kind of look through and identify this stuff really easily. So kind of to conclude here for you, show you real quick. At Full 360, we can help with help with your Redshift migration by sizing and pricing your Redshift infrastructure. We can help you evaluate your SQL and rewrite your SQL if necessary. So if you're coming from an existing row-based system, we can help you convert your existing code to code that will work on Redshift, and also to tuning and maintaining your Redshift cluster, including the actual compression and encoding attributes that help to really get the benefits of the columnar storage. We also can help you integrate your data infrastructure with AWS, help you prepare your data extracts from source systems for the easy Redshift ingestion, data pre-processing or massaging, and also help you set up your VPC and the secure links to transfer your data to your on-premises data center or your corporate network. We're also experienced with helping out with other data warehousing issues like star schema design, ETL or ELT, extract, transform, load, basically your load process to get your data from your source system into Redshift. Any data process management, such as metadata management, for example, and any OLAP and BI reporting. In addition, we can help manage the entire data warehouse infrastructure as a service. One thing I kind of missed here is on my initial slide is just it give you an overview of what we do. We are the only, as Full 360, we are the only systems integrator focused on columnar databases in the cloud, business intelligence and data warehousing in the cloud, and applying DevOps to BI and data warehousing. This is where we get a lot of efficiency by being able to manage the infrastructure through code as opposed to manually provisioning stuff. And the relationship with Amazon, we've been an inaugural cloud systems integration partner since 2008, one of the first people working with the cloud. And we are currently a AWS premier consulting partner. And of course, we are one of the first Redshift system integration partners, and I've been personally working with Redshift since the day it was available for us to work with in the preview. So that's what I got for you.
Great, thanks, Jeremy. Yeah, can you put control back to me? I'll just finish up with a few slides, and we'll go to Q&A.
Right.
A few questions came in for you too in the process, so if you can.
Let me just switch to control. Ready. Just one moment. Right. Sorry, who do I switch it to? Amazon Web Services Organizer?
No.
I'm sorry, who on the list should I switch it to?
I think it's already done, Jeremy.
Okay.
I lost my slide. There it is. Oh, and there's your introductory slide, so sorry about that. Okay, so let's finish up. We're going to really talk about getting started with Redshift and look at a very brief look at how customers are adopting Redshift. Because it's so easy to use, it's been deployed very quickly into several simple use cases that we find pretty compelling to share. So this is one we call the reporting warehouse. The idea here is, of course, that data flows from relational, a highly structured data store into Redshift, a highly structured data store, and is available then for BI and reporting. So I think the immediate benefit here, the traditional warehouse benefit is obvious, okay? You can do your transforms, your enrichment, and your analyses on that data. But what people are doing, because Redshift enables them to bring in lower value workloads and data sets very quickly into an analytical environment, again at very low cost, is that people are using it for simply accelerating their operational reporting. So this is a conceptual diagram, by the way. It's not strictly architectural. It really just describes the flow of data through an integrated environment. So transactional data in relational, analytical data in Redshift. So reports are the symptom why this is a compelling use case is when reports struggle to complete fast enough in the OLTP system, really because it gets too busy, conflict perhaps with OLTP processes, as well as just physical data set size. So as those things grow, the problem only gets worse. But as well as increasing performance, we're seeing customers realizing very significant savings in storage compared to storing it in their OLTP database. Data is significantly compressed. That's the nature of Redshift. It does a lot of compression, columnar. That's a factor of a columnar data store. And when tables are moved into Redshift, their indexes stay behind. They don't have to come with them. The reason is because the columnar storage is optimized, already pre-optimized to run large queries without indexes. And because Redshift is fast and easy to deploy and the pricing is pay-as-you-go, we're also seeing a lot of new short-term use cases emerge. Now this is where like experimentation on previously unanalyzed data sets, that's becoming quite popular. As customers just look to discover new patterns and trends in their data that was perhaps previously too much effort or too much cost to look at before. Periodic reporting is also a popular short-term use case, especially when all the reports are run in the space of a few days and not looked at either side of that. So that's a case where you could just spin up a Redshift cluster, move the data in, get your reporting done, shut it down, and you just pay the on-demand rates. So that's understandably popular. When data is not in the cloud, or even when it is, I mentioned our BI partners before. These are our data integration partners. Integration with Redshift is not complicated, even if the operational data stores are outside of the Amazon cloud. With VPC and encryption, data protection and security is always present. Performance is really not a problem either. We're working with these data integration partners. You can see them on the list there, and basically the value there is that the data comes in very easily, low effort, wherever it is, either in the cloud or outside the cloud in a managed or hosted environment, into Redshift, and that process is relatively seamless. So regardless of where the databases are located, these partner solutions are designed to move and maintain the data into Redshift with very low effort. The second use case, I mentioned before that data loading into Redshift is optimized for where data is located in S3 or in DynamoDB. So this is what's becoming what we're calling the live archive for structured big data. Structured big data being not logs and unstructured data that lands up in S3, but more the structured stuff where DynamoDB it uses its direct integration with Redshift to take that data that moves at very high velocity and move it into basically a SQL data store for analysis and reporting. So the optimal use cases for DynamoDB require data durability, a highly durable data store, but one that moves really fast, very low latency, very high throughput. That's a typical characteristic of a DynamoDB use case. So such applications like online voting, registration, gaming, digital advertising, all very popular on DynamoDB. So as an outcome of improving the way we, let's just call it operational excellence and the SSD technology advances, DynamoDB recently announced quite a large price reduction, saving customers up to 85% of the previous price. So the combination with Redshift now, since we've got these both very aggressive and popular products, but aggressively priced, what it does, it enables customers to understand their data no matter where it's stored, no matter how fast it needs to be managed, moving it straight in from DynamoDB into Redshift. That keeps the footprint smaller in DynamoDB, which is what you want in a hot data store, and it gives you obviously the full experience of analytics once it's in Redshift. The third example is kind of where we're talking about cloud ETL, and this is more I think the do-it-yourself function. ETL is often a partner or a technology-led solution, but it's just as often these days we find a do-it-yourself function within many companies, and Hadoop is emerging as a major technology that enables this. So with Redshift, Hadoop, and specifically Amazon Elastic MapReduce, which is our managed Hadoop service, is now able to provide an online data store for long histories of previously unstructured data. So what that means is if you have a long history of logs, long history of data, you can keep it online all the time at a very low cost and obviously do a ton of analysis against that. The good news for the data scientists who own Hadoop and the stack, and they do a lot of crunching and integration and correlation within that technology, it frees them up to continue to push the boundaries of their big data experimentation and analysis with something like EMR. And what it does, it enables users to self-serve from Redshift using SQL tools, normal basic SQL tools and multi-dimensional analysis, because the raw data in Redshift enables them to look at it any way. They don't have to aggregate or build interim models. So that frees up both kind of parties to do what they want to do best. And this is, we've seen quite a bit of this, and it's becoming very popular, the integration between these two. So just to wrap up, and we're going to go to Q&A, so if you have questions, thank you for them. Just please put them in the chat, and we're going to get through as many as we can. The design goals for Redshift: fast, low cost, and easy to get started, easy to use. We are getting very strong feedback from our customers. Some are claiming up to 50 times faster. We're seeing exponential gains in performance. This type of feedback is not unusual. We're seeing a lot of that, which is rewarding for us, because obviously the team who built this were very, very aggressive about reducing I/O and improving the ultimate performance throughput of Redshift. In terms of cost, I think there's two real metrics. They're less than $1 an hour to get started, and less than $1,000 a terabyte to run Redshift for an entire year. So, you know, all the instance types move from those different numbers, but those are the two primary numbers that people need to be aware of, I think. And to get started, really just visit the Redshift page. Obviously, from the management console, you can launch and go into that. Please visit our partner page too if you have partners and you want to work with them on your Redshift integration or integrating an ETL or a BI technology. More than happy to help on that too. So that's it for this session. If there are any questions, we're going to go to the panel now, and we have a special panelist, guest panelist, Rahul Pathak, who is the senior product manager who basically looks after Redshift and brought it to market for us. Hi Rahul, how are you?
Doing well, David. Thank you. Hi everybody. Thanks for joining us.
I can't read them.
We'll just pick them up.
Do you want to read them aloud?
So we'll get through as many questions as we can. I'll read them aloud and then answer them. So one of the questions is, do you still need Cube or OLAP technology when using Redshift? Really, it depends. I mean, we've designed Redshift so you can use your BI tool of choice. The columnar MPP architecture does deliver extremely high performance. So in some cases, you may be able to get by just going to the system directly. However, your BI layer does provide other benefits and can help especially if you have tens of thousands of users hitting it. So it's something that we recommend you test. So there's a question about importing structured tab delimited data, and there was also a question about importing CSVs. Really, with Redshift, we recommend you put your data onto S3, use any single byte delimiter character of choice, and on the copy command, you can specify what delimiter your data uses. So really, any columnar delimited data is very easy to import into Redshift. And we recommend having that data split into multiple files so that your cluster can load each node in parallel to maximize your throughput. There's a question about what are all the options for loading data into Redshift. So we recommend using the copy command from S3 or DynamoDB, as David talked about. You can also use SQL inserts, but the performance there is much lower because you're not doing a parallel insert. We do recommend, if you are going to use SQL inserts, to do essentially multi-statement inserts to maximize your performance there. So a range of options. And you can use your ETL tools of choice really to get your data onto S3 and copy from there. And then Informatica, Talend, and Attunity also have built-in integrations for Redshift. Let's see. So the one question is, if you know that data will typically be filtered by certain columns, what optimizations and partitioning can you do? So really, we've designed Redshift to be simple, relatively simple to optimize. The choices you make are around your sort key, which is how is your data sorted. So for example, timestamps are an obvious one to use as a sort key. And that allows Redshift to take advantage of features like zone maps and really just focus on the data that you need. And then the other variable there is the distribution key, essentially how you partition your data, distribute your data across nodes. And typically we recommend choosing a distribution key that allows the majority of your joins to be local to the nodes themselves rather than going over the network. In spite of the high-performance network, the really high-performance storage subsystem will deliver better join performance if they are co-located. And then compression and column encoding is another one. This is one that Redshift handles automatically for you when you're loading data. It will sample and pick the optimal choice for the column. Related question about whether Redshift manages striping data across spindles or nodes. We stripe at the slice level. This is in the documentation. There are, I believe, 2 slices on the single XL and 16 slices on the 8XL, and we will distribute across those. And then to the question as well, there are 3 spindles on a single XL node and 24 spindles on the 8XL. So we try and maximize the performance of the hardware subsystem. So there's a question about Redshift and data pipeline. So this integration is something that we're working on improving today. You can use them in concert. However, you have to use data pipeline to trigger a script that runs on an EC2 instance. So Redshift isn't a directly supported target, but you can get it to work together. And if you do run into those questions, I'm sure we can point you to some documentation that will help make that clear. There's a question about having multiple sort keys. At the moment, you can have just one sort key, and you can use multiple columns to create a composite sort key. And for situations where you need to have your data sorted in more than one way, we recommend essentially having separate tables using different sort keys. Easiest way to get data into Redshift, really the simplest way to think about this is get your data onto S3, for which you have a range of options ranging from multi-part uploads yourself, working with partners that can provide high throughput connections that will essentially saturate your upload bandwidth. And you also have other options within AWS. There's Direct Connect, which allows you to essentially lease a 1 gig or 10 gig Ethernet connection directly between your premise and the AWS cloud. And there's also AWS Import-Export, which allows you to ship drives for big one-time loads. So a range of options there. And then you obviously have the SQL functionality as well, but that is, again, from a performance perspective, not optimal. So one question about having all the Postgres DML. So really you have access to virtually all of that. Some of the things to keep in mind are we don't support all of the Postgres data types, and we do list out what we do and don't support and where we deviate from that in our documentation. But in general, you should be able to use standard SQL DDL and DML to do what you need to do. So there's a question about how complex the SQL can be, whether stored procedures are available. So SQL can really be as complex as you want it to be. We've had customers really had no problem moving over complex queries from other systems into Redshift. You know, from the perspective of stored procedures, we don't currently support those, and you know, we have heard requests for them, and we're always evaluating based on customer feedback. So if you do have those requirements, our forum is a great place to do it, and we pay close attention to those. So there's a question about enforcing uniqueness on columns. This is something that you will have to handle outside of Redshift. Redshift does not enforce uniqueness. It uses the keys as hints for the query optimizer, but doesn't actually enforce it in the data warehouse. That's something to keep in mind when you're coming over. Most of our customers who are bringing data out of existing relational stores already have that taken care of on the inbound side, but it's something to watch out for. We do support window functions. They're listed in our documentation, and you can have a look there as to the precise ones that are being supported. I don't have a specific answer right now on dense and rank, but it's published there. And if you do have a use case for those or anything that we don't support, again, please let us know on our forums. We always really appreciate the feedback. There's a question about SQL views, and I think we'll have to get back to you on that. I believe we do, but the documentation has a complete SQL reference. I'm just going down trying to get as many questions as I can answer here. So there's a question about what version of PostgreSQL. So we recommend PostgreSQL 8.4. It's important to keep in mind that Redshift is not Postgres. Redshift, we use the Postgres wire protocol, but it's its own database engine behind the scenes. So there's a question here about distribution across nodes happening during a load. And the answer is we recommend you split your data into multiple files. However, you don't need to worry about distribution. Essentially, when you run the copy, the leader node will load each compute node in parallel, and that's why we need multiple files so we can do that parallel load. Data will then be distributed according to your distribution key, and that will automatically be transferred across the network connection between nodes if it's needed. And there's a question here about multi-tenant SaaS models and Redshift. So we do have customers doing this, but really we recommend that you create your own proxy layer between your application and the database so you can get a handle on exactly who's using what resources on your data warehouse and can manage your query distribution, et cetera, at that level. There isn't native multi-tenancy supported within Redshift. But it's it's a powerful high-performance data warehouse, and customers are being able to do that themselves. So there's a question about VPC and the newly announced VPC by default. And Redshift supports Amazon VPC completely, and as soon as customers have access to VPC by default, that'll be supported as well. And then, as David mentioned, in addition to VPC, we have transparent data encryption and also support SSL. Thank you, everyone.
Hi, everyone. Thanks. We're out of time, but thank you for all the questions. We had way more than we were able to get through. So thanks very much. Let me put the top link on again. There is a link there to the where we store these webinars, and we announce upcoming webinars. And of course, you can always visit the Redshift homepage and sign up to the next one. So we'll be doing this as a series. So we'll be back in a few weeks. But that's it for now. Thanks for joining. Bye bye.